What we're going to be looking at today is to continue working through weird-sized multiplying of matrices. And we're also going to start talking about something that's called a determinant. What we're looking about with this determinant is it's just basic calculation. We're not really getting involved with what it's going to be used for quite yet, but you will find out as we get into using this thing called a determinant, it will help you to solve systems of equations rapidly. So let's continue where we were left off with our matrix multiplication styles. Today what I want to do is start with one that isn't a square multiplied by a square one. Now what we have here is, remember, when you're talking about matrices, do rows go first or columns? Rows. And rows are the ones that go across. Yeah, exactly. Row, your book. So matrix A is 3 rows, 2 columns. And matrix B is?
2 rows, 2 columns.
It's 2 by 2. Do these middle numbers match up?
Yeah.
So can I multiply these together?
Yeah.
Yes. What will the result matrix dimensions be? It will be a 3 by 2, which means it'll have 3 rows and how many columns?
2.
How many times did I write down that first matrix? 2.
2.
So we start by writing down that first matrix twice. -2, 1, 6, 3, -4, 0. So -2, 1, 6, 3, -4, and 0. That is my first thing to do. By doing that, I am, I don't know if you want to call it shortcutting, but I am making my life a little bit easier in the long run. Now, all I have to do is start at the top left of the other matrix and start filling in the columns. And remember, I'm working downward here. And then 3s and 4s. Okay. Now you have 4 simple math things, expressions to fill in. Okay. Move this up a hair. So I know that my answer is going to be a 3 by 2. And the entries go as following: 2 plus -6. -1 and 8. -6 and 0.
Oh.
16, wait, -16 and 3 is 13, -13.
Oh.
18. Yeah, sorry, that's it. There.
6 plus.
Okay. So when you're setting up multiplication, biggest thing that I can tell you is watch your dimensions and just make sure you're recopying things down correctly. It's not that the arithmetic here is going to be all that difficult. What's going to be difficult is forgetting where you are within the problem. What's that? I try. You should make it like a list of things that I.
Yeah, we just did that in communities.
Of what? List that people say?
List of quotations that Benjamin Franklin said.
So you're comparing me to an awesome person. Pretty soon my name will be on the $11 bill. You didn't know that?
Mr. Murphy.
Why wouldn't there be? You didn't get the biggest. And you gave him an $11 bill.
Paper money is slowly becoming out.
We made the $2 bill.
You need a $7 bill.
We already have a $2 bill.
So what's the
Yeah. Why are you bad mouthing $11?
My name is Peter.
Who here wants an $11 bill?
I want to. That's
Everybody wants
That is-
Try this one.
I want a $13.
So let's see here. Let's finish this one out. One. All right. So we're left with this. And like I said, with any hope, -3 and -6 is -9. 3 and 4 is 7. 2. -3, 2, 1. 3, 2, 1. Yay! Nothing. Let's talk about determinants. We'll go into the word problem stuff next week. You can use matrices and matrix multiplication really easily with certain types of matrices, certain types of word problems. What's that?
They did that, like, put your hand up by your face to see if you have cancer, and he picked up his calculator and
Wow. Anyway, today we are going to continue a discussion of other things about the matrices, and one of the things we're going to talk about today is called a determinant. A determinant is used when we are working with generally square matrices. I know that there's nothing on that phone that's helping you right now, so I wouldn't worry about it. The determinant itself, we're going to solve with 2x2s, 3x3s. I've never really done a 4x4. Could you? Sure. There's no reason to though. Like I said, we use determinants to help solve systems of equations. And if you think about it, when you have a system of equation, you have, let's say we have a variable 2 equation. How many entries does a 2 equation, 2 variable problem have? How many total entries are there? How many numbers are there?
2.
In 2 equations, 2 variables.
4.
6 of them. You've got coefficient, answer, right? So there's 6 values in a 2 equation setup. What's going to happen here is that as we learn how to use determinants, you're going to be able to work with matrices real fast in solving these systems. You're going to find it's so much easier to use a determinant, Kramer's rule, and things like that nature to solve systems than any other method we've ever seen. But first, we need to talk about what a determinant is. Now, I don't want you to get lost in the language here, and a lot of times what I like to do is start by saying that we have a matrix A, and I'm going to make it real easy values. 1, 2, 3, 4. And I want to find what is called the determinant of A, or sometimes you'll see it written like this. It's basically the stuff in the matrix with uprights as opposed to the brackets. Those uprights do not stand for absolute value when the numbers are squared, when they're written in rows and columns like that. It stands for determinant. Now, what occurs here is that you are working with the diagonals within the matrices. Now, in this case, when we're looking at a 2x2 matrix, it's really simple. There's only 2 diagonals. There's only 2 possible diagonals. You've got a downward diagonal and an upward diagonal. What you do is you take the downward diagonal first. And what I would do is multiply those 2 values together. To that, I'm going to subtract the upward diagonal. And you get -2. So the determinant is equal to -2. Okay? Now, like I said, third hour is going, well, what does that mean? What does that mean? It really means nothing to you right now. But Tuesday, you'll be like, But we have to be able to calculate these. They're very simple to do as a 2x2. I will remind you, watch your signs. You'll be multiplying things together that have negatives and positive values. Your determinants may be positive, your determinants may be negative. There is no rule that says they have to be one way or another. And you're going to see how that works here in a little while as well. Okay? Once again, if I have a 2x2 matrix and I want to find the determinant of a 2x2, we always start with our downward diagonal, and we multiply those entries together. In this case, I get 1 times 5. To that, I'm going to subtract my upward diagonal. Ooh, I have a blue highlighter.
6.
I had a blue highlighter.
No.
What's your answer? Shall we make this more complicated?
No.
Let's go to 3x3s.
What?
Now, once again,
Oh, man.
don't write this out. This is a whole bunch of mumbo jumbo.
4 times 1 times 5.
No, 20. Anyway, so what happens here, and what I want you to look at, just see how they're going downward diagonal, downward diagonal, downward diagonal. And then they subtracted upward diagonal, upward diagonal, upward diagonal. Here comes the trick part. When you are working with a 3x3 square matrix, and let's use this as our example. Oops, let me put my uprights. I'm going to find the determinant of this matrix. Remember, we're only going to be solving for determinants of matrices that are square. 3x3, 2x2s. Bless you. I don't know if we're going to do a 4x4 by hand. It tends to be, yeah. I don't think we have any problems to tell the truth, and you end up looking at 4x4. But anyway, so once you get this one written out, remember, we always start with all the downward diagonals. We find the sum of the downward diagonals, and then we subtract the sum of the upward diagonals. We'll make it look like this. Okay? Now, each one of these problems has 3 downward diagonals and 3 upward diagonals. Here's what happens, and this is where I want you to pay close attention. All of your diagonals in a 3x3 will have how many entries? Good. They're going to have 3 of them. So my first downward diagonal is 4, 1, 5.
See, I was right.
You're right. You get 4 times 1 times 5. To that, I have to add the next downward diagonal. Good. 2, 0, and then what is the third number to match that up? 2.
How does that match up there?
I'll show you. In order for these things to match up, the way that this works is, let's say I need to find that next 3-numbered diagonal. If you take this first column and you replicate it outside of the determinant bar, so see how I'm getting 2, 0, 2? Then if I replicate the middle one, I have 2, 1, negative 3. So this third downward diagonal would be the 1, 1, negative 3. See how that works? That's what's occurring. Now, I never write that out. I always start with going my downward diagonal with my 3 in a row. I move up 1, 2, 0, and I need a singular number down below to match up. Then I have the single one on top, the next 2. Okay? So then your last diagonal was at negative 1, 1, negative 3. So those are the sums of the multiplication of all of my downward diagonals. What I do is I figure out what that value is. 20, 0, and 3. Otherwise known as 3. So the downward diagonals are 23. And to that, I need to subtract all of the upward diagonals. here's where you have to be very, very cautious. Don't do it all at once. Figure out what all of your upward diagonals are going to wind up equaling before you subtract it out. Usually students will take and write this all out, and they'll subtract just one of the upward diagonals, and they're going to be wrong and cry. You won't cry, but you know. So if I'm going with my upward diagonals, I start with 2, 1, negative 1. To that I have to add negative 3, 0, and 4. And lastly, it's 5, 1, and 2. So that whole upward diagonal winds up equaling negative 2, 0, and 10. Otherwise known as 8. So I get 23 minus 8, which is 15. So my determinant in this case is 15. For right now, the determinant is going to be some value. It's either going to be positive or negative. There's no rule as to which one it has to be. But that's what we're looking at being able to do. So when we're trying to find determinants of these 3x3s, if you want to replicate those 2 extra columns on the outside, go for it. You just got to remember which way you're going. Okay? It's not that bad of an idea. Let's try another one. You guys all got this one down? I want to skip ahead.
Yeah.
We're all right?
Yeah.
All right. Let's go ahead and get the determinant of this one. Remember, you want to find all the downward before you find the upward. Okay? Go for it. I'll give you a second to try it. I'm going to start filling in values.
We'll see. We do show a lot. Let's see. Yeah, that's what you guys got there.
Oh, I see.
It's all.
Oh.
That's a 0.
Oh,
crap. It's a competition.
Stupid.
They got hundreds on the test.
What you guys think? Watch
The 2 times 0 times 4, we made this 8.
Negative 25.
You know why? You didn't have brackets on.
No, we messed up on that other one.
Minus the result.
Yep. If you guys got negative 1 for an answer, the reason why it's wrong is because you did not put brackets around everything in here. You subtracted 0, then you added 12, hence why you got negative 1. You got to put, if you're typing it through it as a string, you should get that. Yes, sir.
I feel like such a fool.
Watch your values. You might have swap out your values somewhere. Okay.
I'm ready.
You minus the result, so even if the result is positive, then you minus what
What's that? We're subtracting the result. You take all the up and the down, subtract all the up. Guys, guess. Did you enter it in? Did we get it right? Did you enter it in? Take your calculators out. There's a button.
There's always a button. There's tons of buttons.
Go to your matrix button again. What I want to do is create a 3x3. So you hit second, matrix. Go to matrix A, slide over to edit, hit enter. When we do that, you just change it from whatever it was, you just make it 3x3. And then you enter in all of those values. I believe I already have them in here. 2, negative 1, 3, negative 2, 0, 1, and 1, 2, 4. Once you get those values entered in, you hit second matrix, move over one spot to where it says math, and there's a button that says DET. Enter. Oh, I hit the wrong, I had to clear out of it. Sorry, my bad, I got to clear out of there first. Second matrix, math, determinant. And I have to figure out what matrix I want to take the determinant of. Well, I've called it matrix A in my calculator. And hit enter.
Right?
Take a point.
Wait, how do we get out of it?
Hit second mode, that it just clears you off the screen. Now, as I've said, maybe once or twice now, there will be calculator, non-calculator parts. When we use the calculator for these things, you need to be able to be proficient with the button presses and the order in which they go and how these things tie together. Because when you solve systems via determinants and Kramer's rule and things like that, you're going to be using your calculator.
Got it.
Okay? I don't know if I'm going to make you do it by hand or not. I probably won't. Maybe a 2x2 I'll make you do by hand, but anything larger than that, you don't want to. 2x2 system by hand with using Kramer's rule. I might do that with you guys. You're good for that. We don't know yet. We're not there. One other thing that we are going to discuss quickly here with determinants. Believe it or not, you can use the determinant to solve for the area of a triangle. How, you may ask? Well, I will tell you. When you're working with the area of a triangle, if you're given coordinates, you get ordered pairs, x, y, x, y, x, y, for 3 points, correct? Now, that means we're very close to creating a 3x3 matrix, correct?
Yeah.
So all you have to do is take the ordered pairs, 1, 2, it doesn't matter the order what you put them in as long as you keep x's first then y's, 6, 2, 4, 0. And all I need to be able to do in that third row, or excuse me, that third column, is put ones. Because when you multiply something by 1, does it change the value?
Man.
That's why it works. So now all you do is you find this determinant. And do you guys remember how we've done a couple determinants already? They come out negative, sometimes they come out positive.
Yeah.
Can area be negative?
No.
So here's what they do. The determinant comes really close to being the area, but you have to multiply it by either a positive 1/2 or a negative 1/2. So when you calculate your determinant, if it comes out to be negative 25, do you multiply it by positive 1/2 or negative 1/2?
Positive.
Negative 1/2.
Negative.
Can your area be positive, negative? Excuse me.
Yeah.
Right. So it's just one little thing. I'm not even going to do an example like that for you. I'm going to let you guys do that. Because determinant has to be within a square matrix. And by putting the ones in that column, it creates the 3x3 matrix. It works. It's a kind of slick little thing. I want you to do these, but I'm cutting this up a little because I'm cutting out some of the word problem stuff here for tonight. I figure we can attack all that next week while I just in one separate day. It's 212. It's 30 through 34 on 212. And then 218, it will be 16 through 30 evens. Okay? Get those going for the weekend. We will start off with double checking the area of the triangle ones right off the bat. We'll build into what we use with Kramer's rule on Tuesday. So Tuesday is just going to be all the rest of 4.3. Next Wednesday, then, we'll tie together all the word problems for the first 3 sections. Thursday, we might have a quiz. I don't know. We'll figure that out. All right? Exactly.